we'll keep going through some of the questions that have been posted. Let's see here. Does Gurobi Pi solutions show dual certificates? So you're talking about like dual values. Definitely, you can extract those. At things like reduced costs and things of that nature as well. Each of those can be extracted. Look at it. Look at our documentation, and you'll see examples about how to extract all of that information from a solved LP or MIP. Can Gurobi
and in particular on duals, so those are very mathematically well defined for continuous problems, so such as LP, or even if you went into quadratic problems. They're actually not well defined for mixed integer problems because of the integrality of that problem. So you have a couple options if you're trying to kind of get at that same piece of data. And for those who aren't familiar with what people might use a dual for, it kind of helps you understand, if I were to relax this constraint, how much is my objective going to change? And so people use this a lot when trying to understand how to make decisions that are maybe kind of on the edge of the optimization problem. So, what happens if I increase the capacity of my warehouse, or what happens if I were to buy another truck for my FedEx route, things like that. But you do have some options. So you can run what if scenarios to actually run those tests to try to figure out that value, or you can fix all of the integer variables, resolve that new continuous problem, and get your duals out of that.
Yeah. And for the like the continuous case that we had in the first example, I didn't look at the dual values to say this for sure, but it may have been the case that which facility do we want to look at in expanding. We chose the Birmingham one just because it was a lot smaller in the quantity of what it could produce. But you could look at values like that in order to say, okay, well, what if we expanded this other one, because we would get a better improvement in our objective if we were to expand the capacity of other ones first. So you can use that information in order to make those types of decisions as well. Let's see. Maybe it's not really. What would you recommend to all people that are interested in working in the data science field? Learn mathematical optimization firstly, but no. I would say is I sort of at the very intro sort of rattled off like some of my experience and stuff like that. Before I came to Gurobi, I was I spent a bulk of my career as a data scientist at a large consulting firm, and what I would say, if I were to be re-entering the field as a data scientist, I would recommend getting exposure to a bunch of different types of data, even if it's not fun to deal with. And what I mean by that is, work with video and work with audio, understand those examples, work with geospatial data, work with structured tabular spreadsheet data, because that's what makes different data science problems difficult. If I were someone that was working with very structured tabular data, I have all my spreadsheets, I have all my observations, and I have all of my features, and I have all these values and stuff like that, and I have that, and then all of a sudden someone's like, okay, well, now I want you to do image recognition on a streaming video. It's just like, whoa, okay, where do I even start? It's a very different sort of it's a very different problem in a sense. Eventually you'll make the two sort of converge a little bit, but that would be my number one bit of advice. If you're someone who wants to work in data science, get familiar, have exposure to a bunch of different types of data. Try to understand a little bit of what's happening under the hood. That'll help you figure out better processes, better ways, better approaches. Like understand what XGBoost is doing at least a little bit. Take the time to understand the math there, and that's part of why why when we come up with these trainings, we do have a little bit of the math involved. We do have a little bit, it's sort of unavoidable at some point. So getting that exposure as well, understanding a little bit what happens, and then also understanding from a conceptual conceptual view about what these algorithms are doing. If you're someone who wants to work in data science, you should be able to sort of explain what a neural network is kind of doing. You don't have to get to the, down to the nitty gritty, but that's what I would use as an interview question. I would say, like, draw a quick neural network on a piece of paper and explain a little bit, explain to me what, happened in terms that are understandable. So that would be something else I would recommend as well. And then obviously, to add on top of that, there is a reason why we're doing this training, is because optimization modeling, while it is not, doesn't fall squarely under data science, answers complementary questions, is a natural extension, things like that. So I would broaden that statement to say, don't just understand, machine learning or deep learning, understand statistics, your good old t-tests and understanding distributions, understand basic probability concepts, and then understand, things like mathematical optimization and other sort of ways of doing decision analytics or decision intelligence. Their mathematical optimization isn't the only tool out there, so understand those as well.
Maybe answering another question that was in the chat, touching on whether or not machine learning is used within kind of Gurobi's branch and bound algorithm. And the short answer is it's not. That is a field that has been researched in academia, and it's an interesting question. From the optimization perspective, there's certainly optimizers behind a lot of the machine learning methods. So, Jerry talked about lasso, and if you're training neural networks, there's an optimizer behind the scenes, but it is a little bit less common for machine learning to be behind the scenes of an optimizer, but that is an active area of research.
Yeah, definitely. It seems like it would be a pretty good fit there, and it's cool that that area is expanding. Let's see. Can Gurobi optimize arbitrary cost functions that are not linear or quadratic? I believe that once you get past that, we may have some options, but essentially we get to piecewise approximations. Is that correct, Allison?
That is correct. So within Gurobi, you can do, as you mentioned, quadratic and also bilinear, so x times y. But if you go beyond that, so let's say you wanted a log function or a logistic function or something like that, you'll need to use piecewise linear approximations, which are just a bear to code up on your own. So Gurobi actually has tools to do it for you. You just kind of say that you want to use a logistic regression with these couple of constraints or these couple of variables, and then Gurobi will make the piecewise linear approximation for you. There are times where you can kind of do some reformulation in order to still solve things exactly. So if you had x times y times z, you could create a new variable that stands for x times y, and then you take that and multiply it by z. And so then you kind of basically factorize it down into only bilinears. So there are some reformulation options that let you take things beyond bilinear and quadratic, or you can move into the piecewise linear space. But there are other solvers that exist that can do more arbitrary nonlinear functions.
Awesome. Yep. Let's see. Is there any way possible to relax the model when getting infeasible, or continue running after you get infeasible solutions?
Can I take this one? I
Oh,
like this
go for
one.
it.
So
Yeah.
infeasible solutions are just such a frustration to have. So you have two options to try to figure out what's going on. One is exactly what you mentioned, is you relax it. It's called fees relax, and it basically relaxes the constraints, and you can try to minimize how much things get relaxed to try to either be okay with a solution that's a little infeasible, or you can try to kind of pinpoint what needs to be changed to make this problem feasible. That can be used a lot of times in troubleshooting. Crap, I added a bunch of constraints to the model. What did I screw up? Why is it infeasible now? Or this model is running online. It was 99% feasible, and then this one problem was infeasible, so we can run fees relax or the IIS, or infeasibility diagnosis tool, which basically says, look in this subset of constraints, this is where your problem is, to really try to troubleshoot what's going on. It's kind of like the debugging tool of an optimization problem.
Yeah, and I haven't used the IIS tool in practice or anything like that, just sort of using it for learning purposes, but it does make it does a really good job. If you are running problems that are getting into some feasibility issues, definitely check out the learning stuff we have on that tool. So next, a practitioner once told me data scientists provided coefficients for operations research to use as coefficients in objective and constraint equations. Is this generally true, comment, or just a one-time observation? I mean, it all depends on the problem, but I mean, that's what we described, sort of as the number one way for machine learning and data science projects to roll over into mathematical optimization is using those estimating those parameters using machine learning or statistics or anything like that, estimating, I sort of said that, hey, we have this demand that we estimated, for our little problem, but essentially any of those parameters, the cost, how much does it cost to ship something from one place to another? That's going to change over time. There's going to be things that that will influence that cost. And there are options as well. We could easily expand that problem to say, oh, well, should I ship using, USPS? Should I ship using, one of the commercial companies? Should I, ship via ground? Should I ship via air? Should I next day? Should I this, and there adds in all of those options and the prices of those options are going to be changing and things like that. So you can definitely expand the problems and use data science tools to help you estimate those parameters. And I would say another way that that you can sort of use this, machine learning will help flow into an MO problem is maybe so, and I think we have an example on this is clustering. So you may have like a marketing campaign that you want, and you have millions of people or tens of millions of people. If you were to put all of those as individuals into an optimization model and say, how can I target people the best to increase revenue and make sure that they buy stuff and so on and so forth, that may be a lot of unnecessary bits of information that you're adding. You're adding a lot of, if you're making a decision variable for all of your millions of customers, that's probably going to be inefficient. And what you can do is cluster like customers together and give them a profile and say, okay, well, how do I approach a customer of this profile? And then so that's a way to sort of reduce the number of decision variables that you could possibly use in an optimization model by using some clustering at the beginning. Let's see. Oh boy, there's a lot of questions now. So one of Gurobi's competitors, FICO, has technology, FICO Insight. To use that, you don't need to have knowledge, but you essentially use a user interface. I'm quickly reading this question, so apologies if I get it a little bit wrong. Essentially you're asking, does Gurobi have like a nice UI? The answer to that right now is no. Who knows in the future, but right now, essentially, we focus on the solver itself. That's priority number 1, 2, 3, 4. I don't know, I don't know how many it goes down, but that's, having a solver that is fast, reliable, and now we're sort of branching out into other types of problems. So as Allison said, we can deal with bilinear, having that in our problem, convex, non-convex, quadratically constrained, all these sort of stuff. We're sort of branching into that, but so that's what we're focusing on as a company. And then also we are putting effort into making sure that our APIs are nice, and the additional tools that we have to help solve problems like IIS, like multi-objective, multi-scenario, all of those other functionalities. That's the stuff that we tend to focus on. Now, taking a step back and say, okay, well, how can I have someone who maybe doesn't have that expertise, but they could still do optimization by inputting numbers, or using sliders or something like that, looking at maps and being able to build tools from that. That's not something that we have available, but we have a lot of partners that do that exceptionally well. So hop onto our website and we can look at some of those specifically, some of those companies. But that's how we help address that. Is if that's something that you're interested in addition to using Gurobi to solve the actual optimization problem, we have partners that we can connect you with, that'll help you sort of build the UI to give people the power to use optimization that may not necessarily have the skill set to build the model and such.
Yeah, and some of the teams that I worked on in the past maybe they're good at writing math models, but maybe aren't front-end developers. So we've used modeling frameworks that might help us with that user interface. Ames is a pretty popular one. There's certainly ones that are targeted to kind of certain areas. So maybe supply chain with Kinaxis, another of our partners and folks that we work with. So even if you're not necessarily building it like a bespoke user interface for each of your optimization models, they do have some more generic interfaces that can help you kind of, get it a little bit easier to make that user interface so you're not doing it all yourself.
Mm-hmm. Awesome. So let's see here. Do you have a comparison between Highs and Gurobi? I don't know, Allison, do you want to take this one?
I don't have a great comparison there.
Yeah, neither do I.
That question offline.
I was thinking maybe you do, but yeah, sorry, we don't. Maybe that's something that we can dive into and try and get a little bit more understanding, because I'm not really familiar. Let's see. I'm solving a nonlinear MIP using Gurobi. I noticed that the outcome is 1, Gurobi is stuck while trying to find at least one feasible solution. Gurobi accidentally finds the optimal solution with the help of heuristics. The gap is 0. There is nothing between. Do you have experience working with such cases? Any ideas how to improve performance? So essentially, you're getting an all or nothing. Like it's immediately boom. Here's your pre-solves taking care of it, or it just you're getting nothing. No feasible solutions for a while. That's a very interesting problem. Allison, do you have any insights into that?
That's certainly something that happens periodically. And in fact, Gurobi is working pretty hard, kind of in parallel to their regular activities to find these heuristic solutions. So that's a really important part of what Gurobi does. It is going around trying to search for these heuristic solutions, and once it finds one, it's then going to be comparing it with the current best bound. So sometimes it's just this huge step improvement, and we kind of consider that a good success. But it is hard to predict then when you're actually going to finish. So there are certainly a lot of parameters that affect how much effort Gurobi is putting into heuristics. So maybe in this case, If it was a particular heuristic, you can kind of bump up maybe that RENS heuristic, or bump up the amount of time spent on heuristics to get that heuristic found earlier. Another option is to, change some other parameters. So MIP focus is a big one that can really kind of help guide how you want Gurobi to behave. So do you want Gurobi to find feasible solutions quickly? Do you want Gurobi to work on trying to close the gap? Things like that. So I'd encourage you to look at some of those parameters and try different levels to see how that works on your problem. However, there are hundreds, well, over 100 parameters that you could look at. MIP focus is one that's pretty common. But we also have our parameter tuner that Jerry brought up earlier, which kind of helps figure out that tuning for you. And that one's really trying to find different parameters that are continually improving whatever performance metric you're looking at. So typically runtime, but it could be maybe the gap, or it could be your objective value.
And I think that's an interesting comparison of tuning between machine learning and mathematical optimization. Is you tune parameters in machine learning to improve the performance from a accuracy or error, but you tune parameters, you tune things in optimization to make things just run faster. Because you're always, the solution is the solution. You're not going to get something different based off of different tuning. You're still going to get the same solution. It's just you want to get there faster, as opposed to in machine learning, when you tune things, you're going to get a different you're going to get a different fit. You're going to get a different model because you're tuning for something different. So it's an interesting comparison. And going back to the hey, I want a UI built for this stuff, I will have zero shame in plugging Decision Spot. Hassan messaged me saying that's something that they do. So if that's something that you're interested in getting into and looking for someone to help you with that, then reach out to Decision Spot and they should be able to help out maybe. So and lastly, Chase, I did not miss your questions. I tried putting them all together, and I got to be honest, there's a lot of information there, and I haven't been able to sort of put everything together. It seems you have a very specific statistical question, and I'll try my best to paraphrase some of our answers real fast, because I'm not sure of all the components. It seems very specific. So let's see. Is there a guideline? Will Gurobi strictly honor constraints? Well, I'll say this about your third question. Strictly honoring constraints is something that mathematical optimization is required to do. There is no, unless you otherwise specify some slack that you can have, all constraints will be adhered to. They have a lot going on there, so maybe condense all that stuff and we can see if there's a way to answer your questions, because it seems very specific, and I'm not sure how to put it all together right now, so apologies for that. Let's see. I guess, okay, I see a little bit of your, okay. You're modeling with sines and cosines and stuff like that in terms of an objective function. That would be something that would fall into the piecewise linear formulation. You'd need to sort of represent that probably as a set of piecewise linear functions. And that'll probably be the way to approach that using Gurobi. Is there an approach built in Gurobi to re-optimize a model when parameters are updated frequently, such as many times a day? For example, locations of fish vessels or transportation trucks or raw inputs. So is there an approach? So yeah, so I guess is your question, I'll slightly rephrase your question, because you could certainly get a new set of input data and then re-optimize every time. I guess maybe your question is, does Gurobi do that smartly? does it use previous solutions with updated parameters in order to solve the next problem maybe a little bit more efficiently? I'm going to assume that may be your question. And Allison, is there anything on that?
Yeah, I think that sounds about right. And that's what's referred to as real-time optimization. So it's taking whatever the current information is, pulling that into the model, and then resolving. I actually used to work in real-time optimization, so it's near and dear to my heart. You do try as much as possible to use previous information. So you know, when you're writing your model, or if you're maybe updating your machine learning models, those will be updated based on the latest data and kind of including previous data. But for the optimization model itself, your best bet is to use the previous solution. And that's something that Gurobi can take in and usually makes Gurobi do much better. So the previous solution is usually close to optimal, if it is feasible. And so if there's only small changes in the data, that'll usually speed things up quite a bit. In addition to taking a full solution, you can give it a partial solution. So if you only know maybe a few of the variables, their values, or you have a guess that those might be correct, you can feed in a partial solution and Gurobi will do its best to complete that solution and use it as a starting point.
Yeah, I just want to quickly add that the functionality for this is called a warm start. It's a fun name for that. So yeah, thanks, Allison.
Oh, thanks.
Okay. Oh, let's see. Okay. Yeah, Gino, I think that was an expansion upon your current question. Where can I find a guide for converting predictive model into a piecewise linear function? I'm not sure if we have particular documentation about that specifically on our site. We definitely have examples of doing that, of taking certain types of functions and representing them using piecewise linear functions. So maybe take a look at some of those examples on our website in order to sort of see how it's done there and how that may help you decompose your model into piecewise linear.
Yeah, and maybe to add to that, a little bit of a plug for our Gurobi community. So we have a Gurobi community forum. It's kind of our Stack Exchange for the Gurobi world and for the optimization world, where if you have a specific question like that, you can post it there. And, you know, one of our folks in the community or possibly within Gurobi can help, can either point you in the right direction for documentation or maybe even kind of help hold your hand to write such a constraint or objective.
And I don't think Allison would do this herself, so I will do it. She's part of our expert team, which is kind of like a support team, but just much better. And yeah, they love helping with these types of problems, and they have the expertise to definitely help and do all of this. And again, yeah, definitely reaching out to the community would be something that can help. And our expert team is another group of individuals that have the skill set and the knowledge to be able to help do those types of to help with those types of formulations. So they're super awesome, and that's something else that Gurobi offers that other companies may not, is access to a team like that to help you tune models, to help you make sure that your formulations are as sort of crisp and clean as necessary, making sure that you're getting the performance that you want out of Gurobi. The last thing that we want is for you to be a Gurobi customer and then not get the most out of it, because that's not advantageous for us at all. So we definitely put forth the effort to present information, put it out there that can help people get the most out of Gurobi, but then also from our putting our effort to make sure that you as a customer are satisfied with using our solver. So yeah, definitely look into those resources as well. Okay, I think that is it for questions.
I do have one last question, if you don't mind.
Oh no.
I know Jerry and Allison, you had significant work experience working in the industry, implementing mathematical optimization. Could you talk like a little bit about like what percent advantage does something like an exact method bring in? Like, are we talking like 10% over existing methods, or can you put a number to what advantage exact methods can bring in to a business problem?
Right. I'll let Allison give her estimation in a second. I'll put a little bit of context there, and then I'll hand it off. Because what Rahul's talking about is if you use something like simulated annealing or some other type of process that stochastically randomly searches spaces, but maybe does it smartly, but still you're not guaranteed to end up at a global optimal solution. That's something that mathematical optimization does. It's provably optimal that what you get out of this is the optimal solution. So that is an advantage of this type of modeling over doing other things. I guess maybe, Allison, in your specific experience, where you used to, in your work, is there a number that you can provide with a lot of context, with a lot of asterisks, because it's going to be very, very different, I think, by case by case.
Sure. I would say it's been pretty rare that the baseline that we have for a mathematical optimization application is actually, one of those simulated annealing or other derivative-free black box type methods. So I can't quite comment on a number on that, but I would say most of the time, in my experience, a lot of times the baseline is somebody with an Excel spreadsheet. And that somebody is doing some very clever understanding of the system and trying to understand what that solution should be. But if something changes in the world, I don't know, a global pandemic, for example, it's really hard to adjust your mental model to be able to take on this new, very changed situation. And that's a type of thing that an optimization model can really adapt easily to without really missing a step. And I think that's something that we saw a lot in the pandemic, or when there's big kind of unprecedented events, is that your optimizer is still working within the boundaries and your operating envelope to find good solutions where, whatever your heuristic method was, whether it was a person with a spreadsheet or your simulated annealing, is a little bit tougher to adapt to. But in addition to just being faster and making more money, one thing, and I come out of oil and gas most recently, that you get with a global solution and a mathematical optimization solution is the ability to explain that solution. And that's tough to do when, your colleagues have their spreadsheet and saying, this is definitely something we can do, but they have a hard time saying whether or not there's something better out there. Having that provably global solution really goes a long way when you're trying to defend that solution in a meeting, or you're trying to make sure that real-time optimizer stays turned on, and really keep that implemented so you have good uptake with your optimization application.
Yeah, and I would say that what Allison described as moving from spreadsheets to something that actually is provable. That was my experience, my optimization modeling experience. I was working on such models for the U.S. Coast Guard when I was a consultant. So things like how can we do maintenance, perform maintenance optimally. It was just moving to a completely different way of approaching the problem. Spreadsheet to something that's to mathematical optimization. So it was going from barely this is something that does work to something that is to provably optimal. So that type of delta is huge. But I will say that one of our case studies that you can read about, I believe, is with Air France, and they are hyped about a 0.5% cost reduction in their fuel costs. I believe it is. I should be quoting that correctly. I was told exactly how to quote it, and I think that's it. So it all depends on your business, your application. If a 0.5% is a large value, that could be something that you're missing from using other methods. And then, as Allison mentioned, even if you end up with the exact same solution as you did before, now you can be confident that that is the best solution, that there isn't anything else out there that exists that is better. So you can have that confidence. You don't have to worry about it anymore. Like this, that in itself, I think, has some value. Even if you took two different methods, non-MO and MO, and they end up with the same stuff, this is the one that says, yeah, we can prove that it's optimal, and everything else can't. So just within that itself, I think there's some value. We did have one more question come in. What percentage of Gurobi's clients in the industry need to develop stochastic or robust models instead of deterministic? Do you combine ML and MO as alternatives to developing stochastic or robust? Let's see.
Let me take that one.
Yeah, go for it.
Sure. So in the optimization space, a stochastic model is often trying to take into account uncertainty and maybe optimize your expected value of your objective function. Robust optimization is usually when you just want to make sure that, even within kind of the variation of your parameters or your demand forecast, you're definitely going to be feasible. Robust optimization is much easier to solve. And so that's implemented fairly frequently, either kind of directly, as in like, I want to make sure 100% of the time I am feasible, particularly when it comes to safety or things along those lines, you'll see that. But usually it's kind of scaled back a bit, where it's, I want to say that 80% of the time I'm definitely feasible. The stochastic optimization, that tends to make a problem much bigger and much tougher to solve. So it is done sometimes for very important things, maybe longer planning horizon problems, things where you have a little bit of time to not only write the model, but also digest the results. So we talked a little bit about the explainability of optimization. It gets a little bit tougher when you start adding in the stochasticity. So what's usually done kind of more in practice is a little bit more of kind of the what if scenarios. So testing those cases of what if I had 10% more or 10% less demand. You can be a little bit more clever about how you're actually setting up those cases, whether or not basically you have an optimizer at the end of a Monte Carlo simulation or something like that, and you're trying to digest the results from there to understand, what parameters the decision is really sensitive to. If the demand goes up plus or minus 10% and we don't change our decision, we're not really sensitive to that particular demand, but there might be one that might change by 0.1% and suddenly our solution is completely different. And so we might do a little bit more work to try to understand what's going on with that particular demand. But I would say a decent bit of our users are doing more what if scenarios to try to understand what's going on when they have uncertainty than stochastic optimization. We do certainly have some folks that are doing some degree of robust optimization.
Well, I think that is it for the questions. So that we can wrap up this session. Thanks, Allison, for all of your input. Thanks, Rahul, as well, and Hassan for all of your help over the day and particularly in this session. Yeah, we'll leave it there. Remember, tomorrow 11 a.m. sharp, we'll start with a new example and go from there. So I hope everyone has a great rest of your day, and I'll see you tomorrow.